Hello and welcome back to this SlimDevOps episode. It looks around 33 today. Thank you for coming back. If you're watching this on YouTube after the fact, this was originally streamed live on twitch.tv/SlimDevOps. So if you want to join in these sessions interactively, head over to Twitch and give us a follow. Well, I'm joined today by Peter and Ian. Hello, Peter.
Hey, Martin. We redecorated. Look at this.
Apparently,
this
yeah,
great.
yeah. I think it's fitting that Ian, who's joining us from the first time, Ian's from our engineering team. You are joining a very professional-looking stream because none of the graphics were made by me, but actually by Grace, who's working on refreshing our sort of brand and look and feel. So. Those of you that are familiar with Twitch, our Twitch page and our YouTube page and our community pages and the website is all now in beautiful harmony. Looks terrific, I think.
Yeah.
So,
looking good.
Aside from fresh graphics, what else have you been up to, Pete?
Well, we've been busy. We've been doing a lot. We, have been posting some stuff to the blog about testing. I have been doing a lot of work on these Nuxt and node containers that we've been working on as sort of demos. So I'm going to have a blog coming out on some of the minification experience that we went through with that. And then I'm going to continue work on the containers 101 that we've been working on. So people who followed the stream last week, we're getting pretty close. We got our database set up and that's all working well. And now just need to throw a bit of a load balancer and Nginx container on the front of it. And we should be pretty ready to go. So looking forward to sharing that with everybody next week. And then, I've been hearing a lot from Ian on all the work he's been doing on Go on our side. So I'm eager to hear more about that. So.
Yeah, in fact, there's a few parallels with what Ian's going to be presenting today and what we've been trying to work towards. But Ian's going to be presenting a slightly different perspective on Docker Compose today. I've been getting into Docker Compose for fun and hobbies. I'll say using it more for fun and hobbies. So I've been playing some online racing games with my friends, and as is typical when we find a new racing game that we enjoy, we're now embarking on over-engineering it, and we're figuring out how we get more players involved. So we're working on a Docker Compose YAML to define the database server, the game control server, our own APIs to interact with it. So I think I may have something interesting to present on this channel in a few days, because working with Yannick and Eric, who you'll know from our podcast, and even Big Pod has been lending a hand. So I think we may dish that out because it's another take on using Docker Compose to do interesting things.
Well, if you need some testers to practice racing, I definitely would raise my hand for that. So I promise I crash into walls a lot and I'm pretty terrible. So
that's standard fare. Yeah, crashing into walls is definitely our keen skill. So Pete, what are we going to be doing today?
Well, so Ian's going to be walking us through a Go application that he's built, a little sample Go application. Ian, do you want to introduce yourself and tell us a little bit about how you started working at Slim, and then maybe tell us a little bit about this Go container that we're going to be working on, or this Go application, I should say.
Yeah, thank you, Peter. I'm Ian, software engineer at Slim. I got into Go for fun and ended up at Slim. So today we'll look at a sample Go application I wrote. We'll play around with DockerSlim, Postgres, and Redis. I'm looking forward to learning and having fun.
Excellent. Now, for those of you that are watching either now or after the fact, this is the GitHub repository where Ian's Docker Compose file and the golang app as well. Is the Go app in this repository as well, Ian?
Yeah.
Yep. So everything you need is here. I've just pasted that in chat, and for those of you that are watching after the fact, you hopefully have seen that URL and you can head over there and pick that stuff up. So, shall I switch to your desktop, Ian?
Yeah, I'm ready.
Okay,
Let's
then.
go.
While we're getting set up, just want to say hi to Luke. Thanks for joining us, Luke. Thanks to Big Pod, as always, for being here. If you are in the chat, feel free to say hi. Let us know kind of how you found us. If you're into Go applications, if you're into containers, if you caught some of the Nuxt streams and stuff like that, we'd love to hear from you and just know what we can do on stream to kind of say that. But yeah, with that, Ian, take us away.
Thank you, Peter. Yeah, so today we'll look at a sample Go application I played around with. I called it Change Monitor. So the idea here is to watch Postgres container, receive specific events we're interested in, and push them to Redis. The goal is that this could be useful maybe for cache invalidation or caching. Yeah, but mostly just playing around with DockerSlim and Docker, and it might be a little contrived, but yeah, let's look at what we have.
I am sure it's not as contrived as some of the examples that Pete and I presented in the past.
Hey,
yeah,
hey, I like that photo app. Thank you very much.
Okay, so we will start with the entry point. I think Martin has shared the link to the project. Yeah, if you can follow me, let's walk through some code.
Sure.
So under the command folder, we see a main function where we try to initialize our application. On line 8, we call sa.init. Let's follow through that. So we have this strange time.sleep. The idea here is to wait for Postgres and some dependencies to be ready. We then go ahead to set up the connection on line 54 by pulling some environment variables, and we'll create interesting database triggers. So we could look at this. Yeah, so we open a connection with the connection info we've just passed into the function on line 14. We then go ahead to go through this part string, this query string. So the query string has a number of SQL instructions that we would like to process. And what we're really doing here is creating triggers that would allow Postgres to send events through a queue. So these events are buffered and can be processed slowly. So you can see a create or replace function. We have our notify function. We also define how we want the data sent over this queue. Yeah, we build a JSON object where we pass the operation name or a record, old and new. So old and new because we will, in this case, be interested in a change event. So you'll have what the previous state was and the new state. So the same thing here again. What's interesting to note is that there's a separator here with 3 dashes. And this really is just so we can build parts of the string and individually execute the queries,
right?
Which we do here.
Cool.
On line 30. Yeah, eventually there's the connection. Without this, we won't have any events sent over. So this is just part of the bootstrapping.
Okay, so you're connecting to the Postgres DB through Go. Now Go, I mean, just to take a big step back for me who hasn't used it a ton, it's a really good language for sort of back-end applications, talking to databases, sort of surveying. This would replace sort of the API layer that maybe we've built in Python Flask, which is what we did in ours, or another API layer. Is that right? I mean, how hard is it to connect Go to a Postgres database, and what kind of functions does that help serve?
I think it was a little easier than most languages or libraries I've worked with. I think I used a PQ, a common Go library is compatible with Postgres. it was a little straightforward, but not too different from what you'd see with Flask and Python.
Okay. Cool.
Yeah. We'll move away from the trigger. So we have a helper function here, report problem. And here we're trying to receive the connection state on the particular event, the particular listener that we create. And what we're interested in is seeing the connection state changes. And I log on line 70 that 103 is bad. So when we have a disconnect, we would like to log that. We then go ahead to define some parameters that we use to ensure that we reconnect. We then create our listeners. On line 86, you see an active listener where we pass the reconnection parameters that we'd like and our report problem function, so we can be notified whenever the connection state changes.
Right.
So this is a TCP connection to the Postgres container. Yeah, we do the same. So we're interested in two events here. Whenever a field within the table changes, and whenever we receive a new insertion event. So we'll jump and look at the structure of our table. So our table is a little simple, contrived example, where we have a table product with product ID, name, active, quantity, price. And we're interested in two things: whenever active changes and whenever we receive a new insertion event. So if active changes, would like to purge it where the record is not active. If we have an insertion event, would like to cache it to avoid a database hit. So our cache server in this case is Redis. So we pass.
What is Redis? So for people who might not be familiar, like what is that? It's a separate container. It's a separate technology, right? Like what does Redis do for us in this case?
Redis in this case would be a key value store that would be responsible for being the cache server. Yeah, that's a use case,
Okay.
at least in this example.
Okay, so it's going to be a key value cache that we're going to use to kind of store these events.
Exactly.
Okay, cool.
So a little bit of Go stuff just to receive events whenever our application is closed. We create a channel where we can send the events to. So it's a buffered channel. Again, just some Go mechanics there. On line 114, we created a listener. So we have the active listener where we'll receive the active change events, active field change events, and the insert listener where we receive insertion events. So we'd like to handle this in a different execution environment. So we use Go routines in Go, just concurrency mechanics again. And we pass our channel where we'll write the events to. Yeah, let's look at what a listener is like.
Cool.
So the listener, the core of it is a continuous for select loop where we receive events from the listener, this pq.listener, which is the pq library I mentioned earlier. So it uses the Go channel mechanics, so we can read from l.notify and we receive events. When we receive these events, we push them to our event channel, which is pretty much the same with the active event. So a little bit of duplication here. But we call, after the event has been received, we push it to a channel and we process the events on another for select loop. So we run this loop infinitely, and for each event, we again process the event in a Go routine, and we can look at that processing of the event. So
And is a routine in Go that's equivalent to what, like a method in another language, or is that actually something that's like more like an event listener in JavaScript or something like that? Like, what is a Go routine, and how do we understand that?
How would you? I would say it's a lot like a thread, but much cheaper to create. Yeah.
Right. Okay.
Yeah. So
Okay.
we know that the event we'll receive is of a particular table, because we have the schema. We create a map of the schema, but with Go structs. So we expect that an old field and a new field will be the same, only that values will have changed. So we go ahead and define our product event,
Cool.
and it'll have 3 fields: the operation, the old, and the new. So you see this from the trigger that we had earlier, where the JSON build object function here has 3 parameters: the operation, old, and new. So this is really what we're mapping in the data.
It's kind of a nice thing about Postgres is that you can pass JSON objects into it, and it's pretty good about handling them. It's sort of like a little bit of a key value store Mongo database within sort of Postgres, and then now you've taken the Go structs, right? And so that kind of maps directly into that sort of same data object. So the data model is pretty easy to maintain throughout the whole app. Is that right?
Yeah. So Postgres is great, and lots of inbuilt stuff that you can utilize. So upon processing of the event, since we know what the schema looks like, we go ahead and define an instance of a product event. We unmarshal it into this object, so we'll have a product, and based on the event type, we process it differently. So when we have an active change event, in this case, we just set a key on Redis. So on line 113, you see the Redis DB, RDB here is for Redis DB. We set a specific key with the product, but we're only interested in new because we just want to store the new state of that particular field. And if there's any errors, we would just like to just log it. On the insert event, pretty much the same thing. Duplication. But yeah, so that's the overview of the project. A bunch of utilities here and there. That's really the core of it.
Cool. And what's marshal and unmarshal? Like, what are those concepts in Go, and what are those sort of things doing that you were just showing? So is that like kind of grouping objects together and then ungrouping them, or is it different than that?
I would say marshalling is like what JSON stringifying.
Okay.
Yeah, and marshalling is a reverse.
Okay.
That's for us web people, browser people, that's, I guess, the best way to describe it.
Yeah, trying to get my Go to Python language translation dictionary going. So
yeah, like a JSON dumps, and can't remember what it is in Python.
Yeah, so BigPod says it's sort of equivalent to serialization and unserialization. That's sort of what some languages refer to it as. Okay,
I like that.
Nice. Yeah. We could pause momentarily for a question or two, if there are any.
We haven't got any pressing questions at the moment. We've had a few comments that I've dealt with in the chat, but you can continue with your explanation. Yeah. But it's a good reminder, if anyone does have questions about anything that we're describing here, just type them in chat, and we'll factor them in as we go through this.
I have a bit of a question, which is, so we have basically 3 different services that we've identified. So we have sort of the Go application itself, we have the Postgres database, and then we have the Redis cache key value store. Would you network all of those together via Docker Compose file? I see you have a Compose file here. Just tell me if I'm jumping ahead, but how would you think about would you run each of those as a service on your desktop while you're working on it and then bring it up to the cloud? Like, how would you kind of network all of those three systems together?
You're right, through Compose, Docker Compose.
Okay.
We could look at that. Let's look at the Docker file. So we have a Docker file for the only container that needs building here, which is the change monitor container itself. The two other containers are dependencies on the change on the monitor container. So we pull the Golang Alpine, but we use the two-step build.
Multi-stage build. Yeah.
Multi-stage build, yes, thank you. So in the first step, just pass a bunch of optional flags and eventually pull our binary in a Scratch container. The downside here is you don't get a shell, but that's okay. Also super small. That's a plus.
That's why sort of Go is kind of like the container language, right? Like, I mean, it seems like most people who are working with Docker on a regular basis are building things in Go because it does these very small binaries that you can then use this multi-stage build to sort of like have an incredibly small container. Is that right?
Yeah. Cool. Next, we could look at the Compose. So under the services, the first service is a monitor service where we have a specific image. But in this case, let's just comment it out. We have a restart policy, which is just unless stopped, restart, but only if stopped. We don't need this. Then you have a bunch of environment variables. We have a host name, so all these are needed by the monitor container. And you see this interesting enable triggers, which we check for whenever the monitor container starts. The idea here is after the first run, maybe you don't want to recreate the triggers. No harm really if they're recreated. That could be better. We then pass a build context. Here we don't need an image. We could build a container. If I think in this case we always build anyway. And we have our dependencies, so Postgres and cache. So we'll look at Postgres first. Our restart policy here is always restarted, a number of environment variables and interesting volume mounts. So there's the Postgres data volume mount where the actual data is stored. So we see varlib Postgres data. So our data would be inside a volume. And the second is an initdb script. So we have a shell, an SQL script here that would load, create our table, create a database, and load all the products.
I'm laughing a little bit because we definitely could have used you last week when we were trying to init our Postgres database for our app. Mandy, if she's in chat, really helped us out by pointing out that this would be the way that you did it. We struggled through kind of restarting our app maybe 60 times over the course of about an hour, and could have done it all with just what you did here, which is the script to init the database. So, nice little reinforcement learning for us on the stream this week, I
definitely.
guess. We'll have to do that for our app next time. So,
yeah, it was a good discovery. I was a bit confused, but it was interesting to see that Postgres has this initdb. Cool, handy. Then our cache container, where you can see that we're pulling a Redis Alpine image. And a custom command. Here the idea is just to pass a save. But I think you can do without. The default entry point should be good enough.
What does this? What does the save do for you? That tells you how long to save things in cache, basically, or?
I think so. How frequently to write to the RDB file, which in this case could be 20 milliseconds. No idea. Then yeah, that's it. And our volumes at the very bottom on line 47, where we have a cache volume for Redis and the Postgres data volume for Postgres container.
Okay.
Yeah, time to run some code.
Let's do it. Let's see what we got.
So I noticed you were using the GitHub Code Explorer stuff in your browser there.
Yeah, so much easier, convenient too. Looks good too.
Yeah, well, yeah. I mean, at first glance, you don't realize it's a browser. You just think it's Visual Studio Code. But I've started to see this crop up more and more when I see developers working on stuff that they've been using Visual Studio Code for years, and now they tend to be moving their environments to the cloud-based services.
Yeah, and VS Code is awesome. That's
yeah, I think it's pretty much a de facto now.
Yeah, so we will run with a Compose app.
So we've covered sort of the introduction to Docker Compose. So this is going to assemble all of those containers that are referenced in your Compose file as sort of a logical whole.
Yeah.
That's cool.
Okay.
This is with the Postgres and it spinning up and all of that. I'm just flashing back to last week, so I'll have to get over that. But this looks really good.
Well, we'll totally copy this pattern, I think, for our refreshed Docker Compose file.
Yeah. Well, while we spin that up, just to anybody who's new in the stream, we're Slim.AI. We work on kind of containers, container optimization. Ian is one of our engineers showing us some cool stuff he's doing in Go. If you haven't followed us, give us a follow. We do a lot of container-based and kind of Docker and DevOps type streams, and you can find us over at Slim.AI, which is in the top left of our, right above Martin's head. So
indeed. And whilst that container builds, I'll just drop over here. So this is our website here. Oh, I'm on the wrong virtual screen. There we go. So this is our Slim.AI. You can find out everything you need to know about us here. So if container tech and container optimization is your jam, come and say hello, and you can join us in our communities here: Twitch, YouTube, Discord, and discourse on community.slim.ai. Keen to hear from container enthusiasts from all technology frameworks and languages.
Yep. Big Pod says he just did a crazy move and switched to Docker rootless. I don't know what that. I don't even know what that is. Big Pod, what is that? Ian, do you know what Docker rootless is? I haven't heard of that.
No idea.
All right. Big Pod's like our mad scientist, so he'll have to explain to us.
Yeah.
Cool. All right. Is this up and running? Looks good.
I think so. Yeah. So we see the Redis container with a number of logs. The Postgres container. What's interesting here is the initdb scripts being run. You can see we create database. We created the product database and we made a few insertions. And yeah, the database is ready to accept connections. And then you see that the monitor is up and running. And it's now entered the main loop where it's waiting for events. So let's play around with the DB. So I'll get the ID and try to execute into the container.
Cool.
So I'll touch to the GUI prompt. And
cool. All right, so you just shelled into the Postgres container and you're going to try to run some SQL to add some
Yeah.
stuff to the database or do something in the database, which should trigger your Go application to see that change.
Yeah.
Is that right? Okay.
Yeah, that's the idea. But first we could see what was inserted into the database. So we see what the init script did. And so we know that we are interested in two events. The first event is a field change event. So we could trigger a change through an update.
Cool.
There's no autocomplete. So set, I think active. ID is equals to 1, so we could change the first record and update the product ID. Update the active fields to false. I think this needs to be caps. And on this window, on the first tab, we see that we received an event where the product active change event, so the active field changed. The operation here was update, and we have the old record and we have the new record.
Cool.
Yeah, we also see that something happened on Redis.
Right.
And maybe looking into Redis could be interesting too.
Cool. While we do that, quick hello to Cassie Dev. Welcome to the stream. Thanks for saying hi. Let us know if you have any questions. We're going over a Go application that uses Postgres and Redis to detect trigger events.
And so far that we've had a walkthrough of the app itself, which is written in Golang, and then we'll be getting into actually slimming this sort of group of containers that are defined in a Docker Compose file. We'll be using DockerSlim for that. Hello, Formath. Welcome to the stream. Thank you for stopping by.
Yeah. Cool.
Yeah, so we can see on the Redis container that we're able to create a key, which we saw earlier with the Redis set instruction.
Okay.
And we see the new record being written. So the other could be an insert, and we could see what the insert event looks like too.
Okay. It seems like Redis is like added to most kind of application contexts, sort of either as a sidecar or as a cache. Is that pretty standard? This is a pretty standard pattern that we're following to kind of add Redis alongside and use that as a caching mechanism, and then sort of data store in Postgres or Mongo, something like that.
Yeah, seems like a good. I think it's a good tool. It has great documentation and it fits the use case well, the caching use case.
Okay.
And many other use cases. But I think the caching one is the simplest maybe. Cool. I wonder what to name the product. Naming things.
The chat has ideas for product name. Fire them out. We will add them. We'll just give the chat a minute to. What's the best product name?
We won't get any. Product name to insert into the database.
Yeah. Ian, what is Omo? I wanted to ask that. So we have
it's a washing detergent.
A washing detergent.
Oh, it's a washing detergent.
Okay. Yeah, they're all local products. Yeah.
Oh, okay. Okay. So chat, name your favorite washing detergent. At my house, we use Gain. That's what you buy at Costco. So that's
okay.
Mine. But I don't know, Martin. What do you use over there in
Persil,
the UK? Persil. Okay. All right. Big Pod also uses Persil. So Persil is the kind of the favorite right now. So there we go.
Popular in Europe.
There we go.
Yeah. So we see another insert event where the operation was listen for insert event, and we also see that there was something happening on Redis. If we jump over and list the keys again, we see the ID and the name of the table.
Cool.
Thanks for sharing that format. We're having a little cultural exchange on washing detergents there.
Yeah.
So format remembers Omo adverts in France.
Nice. That's awesome.
Yeah. Yeah, that's it. On the idea here, maybe the other thing we could add here is like some sort of TTL. But yeah, that's an aside. So we could try Slim this and see what happens.
Cool. Yeah.
So as we get into
awesome.
slimming, let's just ask. I know there are some of our friends who are in the stream, but if anyone's here for the first time, if you're not familiar with the concept of slimming or minifying containers, just put an X in chat so we know whether we need to sort of cover some of the basic ground on those concepts before we get into wrangling with DockerSlim to make tiny containers tinier.
Yeah. I will say that from what Ian's showed so far with his facility with getting into containers and using Redis and stuff like that, I think his use of DockerSlim is going to look a lot more smooth than my use of DockerSlim, so I'm excited about that.
Okay.
I'm not trying to set up any false expectations for that. So Formath is asking what slimming is, so I think we could go over that real quick.
Yeah, sure. So Formath, we are Slim.AI, as you can see from the URL above my head, and we are the sponsors of an open source project called DockerSlim. And what DockerSlim does, among other things, is take a container, typically a Docker container, as input, and then runs that container, observes what that container utilizes internally while the container is executing, and then generates a new container which is only the things that the container touched, referenced, or used during its execution to create a smaller container which you can then put into production. So we're going to go through that process of using DockerSlim in conjunction with Docker Compose, and some of the advantages of that process are to, well, make your containers smaller so you can be more nimble in deploying containers, but also removing attack surface from containers so that you've got a more secure container. Or my personal favorite is I have big fat well instrumented containers for iterative development, and then instead of putting those big fat containers with lots of unnecessary tooling into production, I can run them through DockerSlim and strip out all of that stuff that might actually cause a problem if you put it into production, in terms of it being greater attack surface and being used island hop, if somebody does compromise part of your infrastructure. So if you've got more questions about DockerSlim and minifying containers, just ask in chat. We'll happily field those, but I'll hand back to Ian.
Yeah, thank you, Martin. I'll stop the compose so we can try run a minification.
Cool. And yeah, if people are interested in reading a bit more, we have some blogs and some documentation on Slim.AI if you want to check that out, or if you want to see the product that we're kind of working on, you can find a sign up link there too. So, yeah. Okay. Yeah, Formath. Well, yeah, if you have those concerns, feel free to reach out. We also have a link to our Discord that you'll find down at the bottom of Slim.AI. So we all hang out there, and there's a bunch of other container enthusiasts that are there, and people kind of share projects and share their experience or ask questions about just containers, DockerSlim, sort of DevOps stuff in general. So if you want to join us over there, please do. And of course, follow the stream, because we do this every week, usually every Thursday, 3 p.m.
So I've just put a link to our Discord channel, so drop in there for quick chat, and I'll also drop in a link to our discourse where longer form discussion takes place. So if you've got any questions or follow up, just connect with us there. We're more than happy to have a conversation.
Yeah. Ian, I want to ask you about this, because you're about to do something pretty exciting that we haven't seen yet. We've talked about this in Discord, but I haven't actually seen this done yet, which is you're going to actually use the compose file in DockerSlim to slim this whole application set. Is that what you're setting up here?
That's the idea, yes. To use the compose file, specify a target for minification, and yeah, let's see what we get. So a note that is important to mention here is that compose minification is currently experimental. Yeah.
Okay, cool. But I think maybe people who have been on the stream have seen us slim things before, and usually we're doing it kind of like on a single container, and we're just really targeting that one. Whereas now you have the Docker Compose file, so you're just kind of targeting the service, which we called monitor here in this case, and saying, given the context of this broader Docker Compose app, I want to slim the monitor container, right? And then DockerSlim will be able to run everything sort of all at once and see like, okay, these things interact. So of course it's calling Postgres, it's calling Redis. Now I've activated all of those things, and then I can slim just this one component of it, and I get a better result, and it's more likely to succeed and all of those kinds of things. So that was the idea behind this feature, I think, right?
Yeah, that's the idea.
Cool. Well, very exciting. All right.
Yeah, so we start with the base command, which is we're trying to build a minified image. Optionally, you could pass a log level. So this could be info debug. You could also say you would like to pull images if they're not found. And pass your compose file. Not sure this is a required parameter, but yeah, I think it's just good to pass it anyway. I don't have any HTTP probing. HTTP probing here would be useful for web services that have an HTTP endpoint. In my case, no HTTP. But then go ahead.
And I suppose you've also got the advantage here that this is a Golang app, so there's a single binary that got produced as sort of your artifact for your application, as opposed to something like Node, where you would probably have dozens, if not hundreds, of other libraries that got pulled in through npm.
Yeah, single binary versus pulling in many dependencies. If I used a bigger image, would probably see a much bigger difference as well over something like Scratch. But yeah, so we specify the service within the compose file that would like to be the target for minification. In this case, it's monitor, and the tag for the output after minification. So in my case, it's monitor-minified v1. Yeah, let's see.
All right. Oh no. This was my fault. I said it was going to work, and so of course it didn't work. So this is completely my fault.
I made a change.
Yeah, did you? Because you took that one command line variable out. Was that right? Maybe you needed that one in there.
The pull, not so much. I think it's a different failure.
Oh, you took you made a few changes to your compose file. I don't know if that would have impacted it, because you were kind of walking me through the compose file code. So that might have. Did that do something?
Yeah.
Volume options must not be specified.
Yeah.
Okay. I'm just looking into some debug logs, so cool.
Volume options must be specified.
Yeah, I suspect the way I am setting up the volumes and the initdb SQL script probably broke something. But I need it for the compose for the compose minification, because if I don't have the initdb scripts mounted, I won't get the table.
Yeah.
Probably a bug somewhere.
Is
Yeah, Big Pud says.
Yeah.
Oh, Big Pod says Ian was the one who fixed this one for me in the first place. So we have to
Oh wow.
Yeah. Format suggests looking at the DAT logs again, please, or the data logs. I think he means he means the output of the DockerSlim logs, just to see the kind of debug logs. So I saw that you switched the output level, the log level, to be debug in this one. So this is the reason for the verbose output.
Yeah.
Okay. Field volume options must not be specified. So.
Yeah. Probably something broken somewhere, and still needs more testing on the compose aspect of it.
Cool. All right.
I don't know if we can make.
Yeah.
Sorry, Peter.
No, go ahead. Go ahead. What were you gonna think? Yeah.
Okay, so Primoz is saying that DockerSlim doesn't like the bind mounts. And
is it a bind mount?
There's bind mounts defined in the and Paintface is pointing out the live demos of the downfall of us all.
Yeah.
Yes. Demo gods.
Yeah.
So.
I see.
But debugging in public is what we do on this show, and we all learn together, and so that's what we're doing. This demo is very crisp up until now, and we were using an experimental feature in DockerSlim to try to use compose. So probably going to run into some things. Do you have an idea of what's going on here, Ian?
What Big Pod says with bind mounts. So I'm assuming it's the host path being mounted that's the issue.
Okay. So you're running again.
Pretty much the same result.
Pretty much the same one, yeah. Cool. Okay. Will that Postgres container spin up at all if you don't have any bind mounts there? That would just be saving data into the container basically, yeah. But I wonder if it would work. Yeah.
Yeah, we might need more time to debug this. Minifying a single image won't be as useful. Yeah, not sure that can run.
Okay. Yeah, I was going to ask, could you do just like DockerSlim build on just the Go container? And I don't know what that will get us, right? Because how big is that Go container that you have right now? Like when you just not DockerSlimming it, but like just spinning up the whole service, if you do that, like how big
individually?
Yeah.
Yeah, we could try that. But the compose demo was fun. But yeah, that's
yeah, we can try to solve this. If we need more time, then that's fine.
So BigBod's also suggesting to test just disabling all the volumes during the minification process.
Yeah.
You may need to comment the volumes keyword because it may throw an error with an empty stanza.
Oh, okay.
Feels like it's. I don't want
That's
to jinx
making
it. I'm just
progress.
going to be quiet. I'm just going to be quiet. I'm just quiet. Not saying anything. Well, it's definitely chattier than the before.
Yeah.
So.
Yeah. Well, it minified it, but we didn't exercise it. That's
Right.
Right.
Yeah, that's the issue.
Oh, okay. So you just basically got the same container back that you had before because we didn't. Postgres
and that's
didn't
because
actually do
there was
anything,
no database created, and that would have caused the app to generate some triggers and what have you.
Yeah.
Right.
Although your container is 4.7 megabytes already, so
yeah, we did generate some profiles, some security profiles, so there's that.
Okay.
But without exercising it, without doing something with it as it tries to minify, it might not be as helpful.
Yeah, so to add some context for people in the chat who might not have seen DockerSlim before, which is we're trying to kind of a compose demo that's a new experimental feature in DockerSlim. And so the way DockerSlim usually works is you spin up a container, it runs the container, it will look using static and dynamic analysis to see what's running inside that container, and then it'll create a functionally equivalent new container that has only what it needs inside of it and nothing that it doesn't. So typical results with like a Python or a Node type of web service container are like you'd start with a 700 megabyte container and then you'd slim it down to like a 25 megabyte container. Now Ian's showing us kind of the Go side of it, which is really cool because Go has this sort of like small binary. He's used a multi-stage build, which is another way of slimming a container. He's started with an Alpine base image, which is yet another way of slimming a container. And so Ian's done kind of everything correct to make this like container as small as possible, and then running it through DockerSlim in the full context of the databases and the app and exercising the whole thing might get a few extra sort of optimizations available. The other thing DockerSlim does that Ian just pointed out is that it also creates a security profile of what's running in that container, an AppArmor and a seccomp profile that you could use later on to kind of lock down your apps. So there is still advantage, even if you're not going to get the sort of like massive slimming of 700 megabytes down to 25 megabytes or something like that. But all we've seen here is we weren't able to exercise the app. So it just DockerSlim basically gave us back the same app that we started with, which again is very small. It's a 4.7 megabyte app. So yeah. So cool.
So I did get the initdb volume to work, but not the data volume, which is okay. Not the data volumes for any of them.
Yeah.
So that's some progress.
Okay. Does the data volume work when? I was just wondering if it was maybe the Redis cache that was the problem. Like, did you try it with just the Postgres? I might have missed that while I was talking.
Yeah, which is okay. We don't really need the volumes in this case. We just need this working. So I think it's fine. Yeah.
Okay. Cool.
It could be. It all could be in memory, and that's okay too. I mean, rather ephemeral.
Yeah, so for this little test app, that would be fine. Obviously, we would figure out the volume issue if we were running this in production and have those volumes go back. Looks like our podcast has joined us, who's a regular visitor and knows a thing or two about databases and has seen us work with databases before. And so Yeah, our podcast. We're using the DockerSlim compose function to try to slim a set of containers using our compose file rather than doing sort of one image at a time, which we've done in the past. So just running into a few challenges with the database volumes. So cool.
So what I'll do next is try to exercise the application. So in this case, it's a little manual, and that's the idea behind this prompt here. So user input required, press enter when you're done using the container. So how I'll exercise it is the same thing we did before, where I try update a record.
So this is slightly more sophisticated and involved with the compared to the manual sort of container stimulation that Pete and I've done in the past, where we've been running the container, which is usually a web app, and then what we've done is we've gone to that running web app in a browser and actually, run it and made it do things in order for DockerSlim to observe it. And whilst we've done that manually in some cases in the past to sort of demonstrate what the process is and what's happening under the hood, the way that you can automate that is by executing your integration tests in that running container in order to exercise as much of the code paths as possible, so that that running app has the best chance possible to sort of see, touch and utilize everything that that application requires whilst it's being observed by DockerSlim.
Yeah. In this case, it's more of a CLI application,
right?
Versus what you have, where you can exercise it by clicking a few links.
Yeah. And in your case, you're very specifically interested in looking at database activity and generating triggers from that database activity for your app to actually wake up and do what it does.
Yeah. That's the idea in this exercising of the container. To connect to the product database and update a record. At least we see that the initDB script ran.
No persil, because that was in our volume from the previous iteration of this set of containers, right? So this is just back to the beginning.
Without the data volume that we just commented out a few moments ago.
Yeah. And this is also very similar. So what's happening in the background? So DockerSlim is actually running right now, and it's watching what's happening in this set of containers.
Yeah.
Right. So this is very similar to actually what we did with the R example that our podcast gave us, which was a CLI app, right? This was you run and you kind of write R code in that application. So we're doing effectively the same thing, except here we're doing it in the context of a Docker composed app. So we have multiple containers running, and we're actually using the Postgres container to fire the Go container, which is the thing that DockerSlim is looking at.
Yeah, which is the target we're trying to minify.
Yep.
So upon running that, ideally we should see in the container logs when we're done exercising, we should see some events being received, but the logs are a bit noisy now. But yeah, let's wait and see. I'll copy this, too long to type.
Cool.
With our parcel.
Yeah. If anybody else wants to suggest their favorite laundry detergent washing powder name, we'll happily put it in the database if it's a winner. But.
Yeah, and I think we're ready.
Cool.
So just hit enter. I was done manually exercising the application. I hit enter, and we see those events, those set events where we have a received event here.
Right. Yeah.
Received notification. So these are all container logs. And yeah, size, not so much of a difference, but I think we have built a better security profile.
So you've referred to building a better security profile. Would you just like to sort of touch on what that other feature of DockerSlim is?
So I think this would be the different Linux security profiles. So a seccomp profile that you can see here in the log entry, where we are able to save this. Let's try open it. I have no idea how seccomp works, but the high level understanding is for Linux capabilities. So you can limit the container and its abilities, for lack of a better word. And up armor profiles,
Yes.
depending on the environment in which you run. Also, I think SE Linux profiles, that would sort of restrict the application, create boundaries around it. And hence, you've built a better security profile. See if we can open this. Yeah, so we see a seccomp profile with a number of system calls. I think this would be in the allowed list. Yeah, seccomp action allow. I don't know. Did we do something? Cool. Yeah.
Cool.
Yeah.
Yeah, I think we were going to do kind of some blog posts on deeper dives into app armor and seccomp and how you'd use them. I think the takeaway here is that DockerSlim is actually using what's running in the container to actually like generate these app armor and seccomp profiles. So theoretically, if you've effectively tested or exercised the container in a comprehensive way, then you'd have an app armor or seccomp profile that is specific to your application.
Yeah.
Whereas it's possible in that example of like the node 700 megabyte container, if you were to just run sort of a generic seccomp profile on that, you might be allowing certain services that shouldn't be getting allowed. Is that?
Yeah. Yes, in effect, yes. It's defining the sandbox that your container is running within.
Cool. Well, that's cool to see. Okay. Well, if anybody in the chat has any other questions, please let us know. Otherwise, I think, Ian, was there anything else that you wanted to show? I think that was a really great demo. Cool to see the DockerSlim Compose functionality coming along and, see kind of some of the ways you can use that. And we've never done Go on the stream before, and I don't think we've ever done a multi-stage build either. So a lot of new concepts and cool stuff to see today. So.
Yeah, and Big Pod is saying, his discovery of the day is Docker rootless, which is running Docker in under regular user accounts, and he's all about that now. He won't be quiet about it, but he's saying in addition to seccomp and app armor, you can totally lock down your container by just running it as an unprivileged user and an unprivileged daemon as well.
Yeah. Nothing from my end. It will be interesting to see what an Ubuntu image would give you in terms of minification.
That would be more significant. Yeah.
Quite. Yeah, but that I guess for next time.
Yeah. We can do that. I mean, we know for a fact that it would remove all of the shells because the Ubuntu image is 72 megabytes for a standard image, and there are some libraries and tooling even in those cloud images that even a big application, a sort of something like Python or Node, which has sort of quite deep requirements, even those tend to eject quite a lot of the base image when they get minified.
Yeah.
Cool.
Right, so what are we going to be doing next week then, Pete? We're going to be making a return to the photo app, and we're going to continue to separate that up into its microservices.
We are, yeah. So we're gonna make some progress on that app, and I think we'll get it up into a place where we can have a fully functioning app working on Docker Compose, and I think that's a good goal. I think maybe we'll try some of this functionality that Ian's just showed us to maybe try slimming some of those containers because they are quite large, a lot bigger than the Go container that Ian was using. And once we get through that, I don't think we'll get to it next week, but 2 weeks from now, we'll have Brendan O'Leary on from GitLab, who's joined us before. But this time we're actually going to code with Brendan. Brendan has a pretty awesome stream over at O'Leary Crew. And he's going to kind of walk us through doing a CI pipeline. So we'll start getting into, we're transitioning from dev to DevOps, and that we're going to start shipping some code through a CI pipeline. And we'll try to set that up. So that'll be 2 weeks from now. But first thing will be getting our photo app righteous and singing. So yeah.
Very good. Right.
BigPod, it is not a train wreck. I mean, last week was a train wreck for sure. Last week was a train wreck. But anytime you ask me to do databases or code JavaScript in public, it's going to be a train wreck. So
also, it's a staple. It's a staple of the stream to not just turn up with a well-dressed, well-rehearsed, code snippet. Ian's turned up and said, "Oh, by the way, there's an experimental feature in DockerSlim. Let's try it out." And last week, hand on heart, we turned up and said, "Well, we're going to have a go at hooking up a Postgres database to this ecosystem of microservices, and we don't actually know where to start with this, but we're going to have a crack at it anyway." They make for more interesting exploration, I think, when you're learning on the fly.
Yeah, absolutely. It's good that you run into a little bit of let's try to work through this problem, because I think that's the way everybody learns. That's what I like to see in other streams. It's always the most interesting stuff.
Eric, I think Eric's saying that we're among friends, and Eric's saying that a lot of his streams also have all sorts of development chaos. That's as it should be, Eric, as it should be.
Yeah, absolutely. So, very cool. Well, Ian, this was cool. This is one of the coolest demos we've seen on this stream. So thanks for showing it to us. It's really, really awesome. So
yeah. Thank you, Martin. Thank you.
Thank you very much. Thank you very much. And we'll be back around about the same time next week. So if you're not followed, please give us a follow, and we'll speak to you then, if not sooner. And if you've got questions, just drop into our discourse or Discord. Ask any questions you like about DockerSlim, container tech in general, the Slim developer platform. We're more than happy to help answer questions and field any inquiries you may have about anything container related. Right, I think we'll put a bow on it and we'll wrap things up there. Thank you very much, Ian. Thanks, Peter. And I look forward to speaking to you again soon. Bye for now.
All right. Bye, everybody. Thank you.
Thank you.